5.1, Day 1, Basic Trigonometric Identities. Our focus is going to be on basic identities that pertain to trigonometry. And an identity is something that is always true. There are a few ground rules that we should put in place. The first is that our text likes to use u as a variable to stand for universal variable. That means u could be theta, it could be alpha, it could be 2x, it could be a minus 4 pi. So when you see u as the universal variable, just think about the fact that it could be replaced with anything. If you like theta, that's great. Okay, the other general rule is that for some of the identities, we can use powers, and the way powers are written is not the same as the way powers are written other places in mathematics. So for example, if we wanted to talk about the cosine of theta, and we wanted that quantity to be squared, okay, we would write it that way. However, the shortcut that gets used in trigonometry is to actually put the square on cosine and then write theta. Another example, if I wanted to write tangent of theta, and I wanted that to be raised to the 5th power, I would actually, the notation would say, write it as tangent to the 5th power of theta. Now, if you're ever going to use your calculator uses this notation. So you'd need parentheses and then the power outside those parentheses. Okay, so you'll see that a lot in this chapter. Let's begin with some basic identities, some things that we already know and accept. The first batch of identities are called the quotient identities. And the quotient identities we used when we were graphing. So tangent of theta could be rewritten as sine of theta over cosine of theta. Okay. The other quotient identity is that cotangent of theta is equivalent to cosine of theta over sine of theta. Those are the quotient identities. A little bigger group would be the reciprocal identities. And I'm going to start using u as a universal variable so we get used to seeing it. So the reciprocal identities would be things like cosecant of u is equivalent to 1 over sine of u. And secant of u is 1 over cosine of u. And cotangent of u is 1 over tangent of u. It would also be true that sine of u is 1 over cosecant of u, and cosine of u is 1 over secant of u, and tangent of u is 1 over cotangent of u. So now we have two groups of identities. We have the quotient identities, which refer to things that you could replace tangent or cotangent with. And then we have our 6 reciprocal identities. Okay, so let's see how our two original rules might come into play. So for example, if in a problem I had secant cubed of 5x. Okay. I could replace that with 1 over cosine cubed of 5x. So what I've got going here is my reciprocal identity for secant. Secant is 1 over cosine. It will work no matter what power I choose to use, so I've chosen to cube secant, so that would just mean that cosine is cubed. And my universal variable was 5x. Let's try that again. Let's say I have tangent to the 4th power of alpha. I've got two things I could replace that with. One of them would be using the reciprocal identity, 1 over cotangent to the 4th of alpha. Or if it will serve my purposes better, I could replace it with sine to the 4th power of alpha over cosine to the 4th power of alpha. And you might say, well, when am I going to use these? Well, I need to put a few more in play before we start to use them. But I just wanted you to see how these powers work. We have one more batch of identities to talk about today. They are the most important in trigonometry and probably in calculus as well. They are the Pythagorean identities, and they come from the Pythagorean theorem, which you might remember talking about the opposite side and the adjacent side and the hypotenuse, and based on where theta was, we created all of our trig ratios. Well, let's call the adjacent side A and the opposite side B and the hypotenuse C. The original Pythagorean theorem says a squared plus b squared equals c squared. So let's call this out in terms of opposite, adjacent, and hypotenuse. So it says the adjacent side squared plus the opposite side squared equals the hypotenuse squared. And someone asked, what if? What if we divided both sides by hypotenuse squared? Well, this side would say adjacent squared divided by hypotenuse squared plus opposite squared divided by hypotenuse squared equals hypotenuse squared divided by itself. So 1. Well, adjacent squared divided by hypotenuse squared would be the same as adjacent divided by hypotenuse squared, opposite divided by hypotenuse squared equals 1. Well, what is adjacent divided by hypotenuse? Well, adjacent divided by hypotenuse is the definition of the cosine of theta squared. And opposite divided by hypotenuse is the definition of sine of theta squared equals 1. So now we have the way it really looks. Cosine squared theta plus sine squared theta equals 1. And this is one of the most important trig identity. It comes like this and with all of its related facts. So it is also true that 1 minus cosine squared theta equals sine squared theta, or 1 minus sine squared theta equals cosine squared theta. Okay, so we did what if and divided by hypotenuse squared. What if instead we had divided both sides by adjacent squared. We would have gotten to adjacent squared divided by adjacent squared plus opposite squared divided by adjacent squared equals hypotenuse squared divided by adjacent squared. Obviously, something divided by itself is 1. Opposite squared divided by adjacent squared would be opposite divided by adjacent quantity squared, but opposite divided by adjacent, well, we know that is tangent of theta squared. Hypotenuse squared divided by adjacent squared is hypotenuse over adjacent quantity squared, and hypotenuse over adjacent is secant of theta squared. So here we have another Pythagorean identity. 1 plus tangent squared theta equals secant squared theta. And again, we get all of its related facts. So secant squared theta minus tangent squared theta equals 1. Secant squared theta minus 1 equals tangent squared theta. And let's complete our little what if by dividing both sides by opposite squared. So we'd get adjacent squared divided by opposite squared plus opposite squared divided by opposite squared equals hypotenuse squared divided by opposite squared. Adjacent divided by opposite is cotangent of theta squared. Opposite divided by itself is 1. Hypotenuse divided by opposite is cosecant of theta squared. So now we have the third Pythagorean identity and all of its related facts. The Pythagorean identities, although they do work for universal variables, they only work for squares. So the Pythagorean identities do not work for cubes or fourth powers or fifth powers or square roots. The other two identities that we discussed today do work for all powers. Okay, tune in to our next video to see some practice of this.